which is which may not be very computationally laborious. So here we will start with an example that how to find those conserved sites. So first of all, it is very similar to the local alignment. We need a matrix of two sequences, and then we have to initialize it by 0. But one difference is that here it moves from from left top to bottom, and one by one we try to solve each column, which is but in Smith Waterman we move from left to right and solve it. And one more thing here, that here we will use one Blosum matrix, that is for pairwise alignment matrix, and we will use this to fill in the matrix. However, similar to the Smith-Waterman, here if the value go below 0, that is negative, then we don't have to go negative, and we have to insert 0 instead of any negative value. So let's start from here. For example, in the first we have already put 0, that is for initialization. Next, now we have to align P and H, and here first there is one initialization cell, so for that we have to initialize it by 0, and then we have to move downwards. And as you know, that similar to the local alignment, we add gaps when we move from up to down or left to right. So here if we move from up to down, we have to add 0 plus gap. Let's say the gap value is -8. So here if we add -8, then that would be 0 plus -8, that is -8. So we don't have to add minus value, so we will add instead 0. Again 0, similar, all the cells, because all the cells will get the gap value, and that will make the value less than 0, that is negative, so we will add 0 instead. Right? Now from the next column, again here there will be 0, and now we have to start aligning the two sequences. For example, here that is P, which is aligning with H. So this H is actually, so what is the score of P and H? We have to look for Blosum matrix, and the Blosum matrix here you can see that P against H is -2, right? So -2, it means we have to add -2 here. So if we add -2 in this 0, this will be 0 plus -2 again, so we have to put 0 instead. Next is A to H, and then again we have to look for the value of A to H, that is again -2. So again when we add 0 plus -2, this is -2, then again 0. For the next, now W and H, for W and H the value is, for W and H, let's see, it is -3 here, this one, -3, so yeah, sorry, this one, so -3, again this is negative, so we will add 0, right? Now H. Now H and H are two different same sequences, so there should be a positive score for it, and for that we have to go and check in the matrix, and here then again H and H is 10, right? So here we will insert a value of 10, which is added in this 0. So we can say that 0 plus 10 equals to 10. So this is the maximum value we can put here. Again, now next E and H, here it is, we will add a gap value here. Gap is actually, this gap score is 8. So, and if we add gap, then it will be 8, and if we add the value from diagonal H, E and H, E and H will be, here you can see E and H value is 0. So if we add 0 plus 0, this is 0, and but if we add gap here, 10 plus -8, this will be 2. So the maximum value is 2 here. In the next next cell again we have to add A and H value we have to check again. For A and H this is -2, which is already highlighted. So again if we add values, so from all those sides, from here 2 minus 8 that will be -6, here it will be -2, so the maximum value is 0. Again E and H, from all the sides, possibly these are two different sequences, though the value will be E and H, that is 0. So the maximum value from all sides is, here you can see here, E and H, this is 0 already highlighted. So maximum value from all sides is 0. Next again here P, again यहाँ पे we will add 0, and then from here P and E and P value we have to check. E and P, that is -1, so this one, this one -1, so here we will add -1, so that will be negative, so we will go with the same value again, that is 0. A and E, again the value was negative, we checked already, that is A and E is -1 here, so we will add 0 here. Now W and E, that is W and E is -3, so again we will add here 0. Now H and E, again that is negative value, that is actually we have already highlighted here, you can see. Cool. W and E, this one, H and E is 0, so the maximum value is 10. Again we have horizontally we add gap, so maximum value is 2 here. Then E and E. Now E and E should be positive value, and that is here 6, this one. So E and E we will add diagonally with 10, so 10 plus 6 equals to 16. Now A and E, here it is negative value, so if we add the gap here, this will be 16 minus 8, that is 8. Now if we E and E again, as we see here that the E and E alignment score is 6, so we will add 6 here, that is the maximum, because if we add gap in 8, that will be 2, so the maximum value is 6. Next is, so now I'll move quickly so that you can have a good idea and you can solve it quickly. A P and A would be negative, so again we will add a 0 here. Then A and A is the positive value, so we will add the what is the positive value here, A plus A, that is 5, right? So here A plus A is 5, so we will add up 0 plus 5, that is 5. Then here in the next from W and A all are negative values, so we will add 0 instead. You can check the matrix if you want to check again. You should have this. You can just search for the Blosum 50 substitution matrix and you can download it and you can then perform it yourself. A and W is, here you can see, -3, so that's why we have added here 0. Again now next, if we move from A to H again, that is a negative value, so we will add here 0. Now if we A and E is negative, but if we see from left to right, we add gap, then the maximum value should be 16 minus 8, that is 8. Now in the next, A and A is the positive alignment. A and A alignment score is 5 from the Blosum matrix, so we will add 16 plus 5, that is 21. So here now there is one different thing from the Smith-Waterman algorithm, that at this point now we have, so it's not 20, this is 21. So at this point we have a score that is above 20. So this repeated match has always a threshold So here if we say that is 20, now if the value moves above the threshold value, then we will make the minimum value of the matrix, that is the difference between the threshold and the total value, so that is 1. So now in the next column we will start with 1 here, right? So this is one thing different, because now we want to differentiate between the the purpose is to find the different aligned sequences of exact sequences. When we will do the when we will build the alignment, you will understand this more better. So now again here, if we add E and A and all the values are negative, but if we add 21 minus 8, that is 13, right? So now from this column the minimum value is 1. We cannot go below 1, right? So P and G is negative, so we will add 1. A and G is negative, we will add 1. W and G is negative, we will add 1. H, G, 1. And now there is as 8. So if we add 8 minus 8 gap, that is 0, that is below 1, so we will add 1 here. Now if we add the gap value with 21 minus 8, that is 13, which is maximum. If we add the for example here A and G negative score is, A and G alignment score is 0, so if we add 8 plus 0, then that will be 8, but if we add 21 minus 8, that is 13, which is the maximum score. So we will just rub this out, this one, right? Okay, now again here if we add the E and G score is, alignment score is minus 3. So if we add E and G score in 21 minus, we add alignment score diagonally, you know that 18 minus 3, that is 21 minus 3, that is 18, right? So now in the next for the next column, again start with the minimum value, that is 1. Now yes, and then again there is a negative value, so that is 1. Then A and A alignment score is 5, the first value. Then we will add 1 plus 5, that is 6. Now again here W and A, that should be negative, so again we will add 1. H and A, that is negative, so again we will add 1. E and A, that is negative, then again we will add 1. Then A and A, now again 5 plus 5, that is 6. And then E and A, there are 3 different values, 13, 6 and 18, so we will select the maximum. So A and E score is minus 1. So if we add 13 minus 1, that is 12. If we add 18 minus 8, that is 10. So the maximum value is diagonal, that is 12, right? So in the next column we will go to, again here W, P, minimum value is 1. Then P and W, that is 1. Now A and W, all the negative, all sides will give negative value. Again 1. WW. Now WW alignment score is, W and W is this one 15. So this so we will add here value 6 plus 15, that is 21. Now if this is again 21, which is already we have reached here, so again we will move forward. H and W will add gap here, so 13. And then E and W we will add gap here because the maximum value is coming from here, 5. And now then A and W, all sides are giving negative value, so we will add 1 here. Then E and W, the E and W score is, E and W is minus 3, this one. not, yeah, minus 3, this one, yeah. So now we will add here 6 minus 3, that is 6 minus 3, that is 3, right? So if we check again E and W, that is minus 3, right? So now in the next, again we will start from here. C, again like minimum value is 1, P negative 1, sorry, and A and W is also 1, so it's already written like 1. The G and W again is negative value, so we will add gap because this is 1, right? And gap W 21 minus 8, that is 13. And now in the next, if we add H and G, there are 3 different values, so we have to check which is maximum. A and G is 0. So let's put A and G, not sorry, A and G, H and G. H and G is minus 2. So we will put here 21 minus 2, that is 19. So this is maximum, because if we see horizontal and vertical, the values are 11. Sorry, not 11, 5. So 19 is bigger than 5, so we will insert 19 here. Right? Next, again, if we add the gap here, the value will be 11. Then if we again add gap here, because all the values are negative in the other, from the other sides, and the last one will be the maximum value between E and G is 1. So now in the third last column, now here we are just finishing it. H and is 1 because there is no negative value, negative value, negative value. Now H and W, we have to add gap here, so the value will be 5. Then H and H, now 13 plus H and H, what is the value of H and H? That is 10. So here we will add 13 plus 10, that is 23. Now the threshold has increased. For example, 23 minus 20, that is 3. So now here we will insert 3 here, and we will move forward. And 23 plus the gap, if we add the gap here, H and E, this will be 15. But if we add H and E score, that is, if we check here E and H, that is 0. So if we add 19 plus 0, so the maximum value is from here, that is 19. Then if we add gap here, 11, and then in the last, if we add E and H again, that is 0. So the maximum value, if we add from here 11 minus 8, that will be 3. 5 plus 0, that is 5. So 5 is greater, so we will add 5 here. Now in the second last column, again, 3 is the minimum value. So we are moving from here. Now from 5, here this is E and W, that is 5. Now 23 and H, so the maximum value is 15 here. Now E and E, so what is the match score of E and E? That is 6. So we will add 6 in 23, that will be 29. So now again the threshold is increased. 29 minus 20, that is 9. So we will add here 9, and then we move forward. We add gap, this is 21, and then if we add gap here, this is no, not gap, I think E and E. If we add the value here, because this is a match, E and E, 11 plus 6, that will be 17, right? So now in the last column, again 9 is the maximum value. 9, A and E are all our misalignments. WE 9, H and E is again if we add gap, that will be less than 9, so 9. And if we add gap here between E and E, that will be 21. And if we add the score here, that is 15 plus E and E is 6, 21. So the maximum value is 21 from both sides, from here and here. So this is 21, and then A and E, that is 28. Why? Because if A and E misalignment score is -1, so 29 minus 1, this is 28, and then the last is 20. E and E, again this is alignment, so 21 plus 6, this is 27. Now we have we have aligned the whole sequences, and if we see that from here we start, if I just change the color, and you can see here that first we have to move from here, because from E there is no alignment, and then from here there is a match here, this one, right? And then from this one we have from here we move here, we have another this match. So if we make alignment of this along the beneath here, so if we start from here, then from E we don't have any sequence aligned here, so this is the first sequence. And now if we see from we directly jump to this side, that is E, sorry, we have to here, this one, this not this one, this is 29. From 29 we have to move upwards. From E and E, this is the first alignment, so we can say that this is a line sequence E and E. Then we have H and H alignment, so we will say that H and H. Then there is a gap between against G. There is no other sequence other than G, so we will add a gap here, G and G. Now from G, W and W, there is another alignment here, so we will say W and W. And then A and A is the next alignment, A, and yes, and then from A there is a G. So again, there is in front of G there is no other sequence, so we will add G here, and then we will add a right. So here we will add a sorry. G and then a gap, right? And from G, now we have to jump again to this sequence, the maximum threshold, that is 21, and again we have to start aligning the sequence. So here A is aligned with A, here you can see, and then E is aligned with E, as you can see here, E is aligned with E, and then W is aligned with, then there is, where is the, it's not, sorry, W, no, E, then there is H, so H is aligned with H. So here you can see that using this algorithm, we have identified two different sides of alignment. Okay, this one, and this one. So there are three different repeated matches out of the total sequence. So here, this algorithm will help you to find the repeated matches. But in you know that in Smith-Waterman, they also try to identify the conserved sites, but using this you will try to identify the exactly common identical sites between the two sequences. So, and this algorithm is known as repeated match algorithm or pairwise alignment, and I hope this will help you to learn about this algorithm. And in the next lectures we will come up with other repeated matches algorithm or other overlap match algorithm and the other HMM based algorithms, so that we will have a complete idea about different methods. Thank you very much. Assalamu alaikum.